Hey everybody, welcome to Houdini Hangout. We're in September now, and hopefully your year is going by well. Nice to have you all here. So for this week, we are going to look into doing some basically a Copernicus simulation using the new flow solver in there. And then we are going to use that to kind of mess with a Vellum simulation and see what we can get up to with that. Excuse me. Hey, everybody. Hi, Zach. Hello, Maitland and KG and Ruben, Sprawa, everybody here known. Welcome, everybody. Hey, just so everybody knows, hey, Crossfader, welcome. I'm trying out a little bit of a different setup than usual. You might not notice anything different, but if you do notice anything that's like drastically different, let me know. I'm just trying some new stuff with my audio and my video, just to try to maybe have a little bit less resources used by that part of my computer. So if you're seeing anything weird or anything like that, feel free to let me know. But hopefully you won't notice anything, because that's the goal here. I also, over the weekend, did something really fun, and I was trying to clean up my computer a little bit. And I was like, I'm just going to clean up a bunch of applications. And I saw a Stream Deck for OBS that I don't use anymore. And I was like, I'm just going to clean that out with like an uninstaller thing that I use. And I was like, yeah, make sure it's all nice and cleaned out. Well, when I cleaned it out, I cleaned out all my preferences for my Stream Deck. So, no, not a new light at all. Nope, not new light. So when I uninstalled the software, I uninstalled all my preferences too, which was super fun and super exciting to do. So I had to rebuild all my Stream Deck stuff, and I've got like a quarter of the things on there. So hopefully it's not anything too crazy. I'm Houdini. Yeah, definitely Houdini 21. And I want to give a little, I am actually using a green screen thing here instead of just using a cutout. So I'm hoping that this will look okay. It seems like it's doing fine, so I'm not too worried about it, but, mostly the audio is what I'm worried about, as usual. But, yeah, so for this session, I just want to make sure that everybody is aware of this, that there was a bug that was recently fixed on this, and that's why I didn't cover this last week. I think it was in 4.468, I want to say, and there was a bit of a memory leak, or there. If you have a certain environment variable set, there's a leak in memory. And so I was playing around with this day of release, and it just basically ate up all my VRAM and RAM and then crashed. So so please don't do what I'm going to do here on the original 440 that came out, because there is a bug there that you will run into and will be not pleasant. Hey, Dimitri, welcome. Glad to have you here. Second stream. Nice to have you. Fractaler, hello everybody. So just be mindful. Don't do this with a version lower than 468. So President of Pudding. It's a wild name. Welcome. Hey. All right. You have 440. Yeah, I would definitely just watch out. It's don't try this at home. No, definitely try it at home. Just don't try it with older versions, because it just eats up your VRAM pretty quickly. It's faster technically, but I would argue that I would rather be a little slower and not crash. So, also, let me try this. If you would like to join the Discord server, you can go to HoudiniHangout.com and get an invite link. Isn't Bill Cosby the president of pudding? I'm not even going to touch that one. Yes, he was the Jell-O spokesperson. I'll say that. Restream bot rude. What was that? What was that in response to President? I don't know what that was in response to. Yeah, so if you want to get an invite link to join the Discord server, you can go there. And did it not like my thing? Hold on here. Hold on a second here. I just want to make sure that this is playing nicely. Sorry, I changed my link there, so I am going to check and see if changed my look at that. Link there, so okay. Did that go through? Does not look like it went through. Maybe. Huh. Anyways, I posted a link and it looks like it's just not happy with that. Okay, good to know. Well, if you want to go to... I'm installing 469. There you go. Yeah, install 469 and you can follow along. All right. Anyways, I guess my link didn't post, which is too bad. Cool. All right. Let's see here. All right. I think that's it. That was all I was going to say. So let me know if anything weird is happening. Like my stream is doing something weird. Hopefully it won't be though. So without any further ado, let's jump over in Houdini and mess around with some stuff. Okay. So kind of the first thing here that we need to do is get some geometry. So what I want to do is I played around with this a little bit already. What I want to do is have some just some basic geometry that's going to be randomly moving around like SOP's geometry, and have that influence like a flow simulation, and then from there have that like map onto a Vellum cloth simulation. So that's kind of my plan. I think there was a little clip like that in the either the sneak peek or in the keynote, but I think there was a little clip like that. So that's what I want to do, and I'm going to play around with something like that. So all right, let's do this. I'm just going to let's see here. Let's do a geometry, and let's call this Sim Copernicus, and I'm gonna make that one purple. Let's go inside here. All right, so we need some points. I'm trying to think of how they're like a isn't there one like that? No. I'll just make a few points here. So what I'm thinking is we'll just kind of move some points around just randomly. So let's see here. What do we want to do? Actually, you know what? I can just do this. I'll just take a sphere instead. Sphere, and we'll scatter some points. That's easy enough. Give us something kind of random to start with. Let's just say like 10 points, something like that. Cool. That's probably hard to see here. Let me make that a little bigger. Maybe we'll do the dark gray background, and I will up the geometry size here, maybe to 5. Cool. Okay, so we've got some points there. Let's see here. We could do... Oh gosh, there's so many different ways we could do this. We could just do like a mountain here, right? Like this. And just do an animation. And we don't want to do noise along vector. We'll just do noise randomly, like so. Let's do this at like 2. And I want to smooth this out a bit so that these are kind of just like randomly moving around. Let me put the time thing on here. All right. Actually, we probably want to shorten this even. So let's do that. 0.5. I'll do this, something like that. And cool. All right, so we've just got some random points there. Sorry, I'm just going to quit something here real quick. All right, so let's do a copy to points. And I think I'm just going to put some, like a box geometry here. And actually, I was thinking about this just before I started. I think what I'm going to do is add some more divisions to this. So let's do polygon, right? Yep. Is it mesh? Does it really matter? There it is. That's what I meant to do. Sorry. Let's do polygon mesh, up the divisions here. Just to have a little bit, maybe a little bit more here that we can actually like get some information from, because we're going to be, you know, calculating their movement and stuff like that. Maybe we do that, like that. Maybe that's a little too fast. I don't know. Cool. And what I was thinking would be kind of cool to do, is to have it like only one of these will be visible at a time. So what we can do is we can do, let's do point velocity here. Let's grab point velocity. And I'm going to do calculate speed. And let's do compute from deformation. Can just do central difference there. Now we've got these kind of flipping around and doing their thing. But most importantly, we have our speed attribute here. So we've got velocity and speed being calculated. Speed is what we'll use. So let's sort here by sorry, I got a little something in my throat there. Let's sort these by attribute. We'll sort them by speed. And then we should reverse point sort, and we can just blast points and 0. And we delete the non-selected there, and this will only give us the very fastest one moving there. So now I've got this kind of weird thing going on here where boxes are kind of randomly moving around and doing their thing. And I think that'll be a little bit more interesting than just having these, I think, kind of all like just jittery weirdness. The one thing I am going to do is I am going to, I think I'm going to delete the attribute here. I'm going to do an attribute delete and get rid of the velocity that we calculated here, because that's what's making it kind of, it's orienting itself that way. So I think it's a little bit more fun like this, where it's just kind of like random, you know, they're kind of all oriented the same way, but we're getting these kind of random, you know, shapes or whatever, or random movements. Okay. So like that. Now I'm making myself think, should it be that, or should I leave it like this? Kind of interesting to see it like that. I don't know. Let's try that. And I just want to see if this gives us any different values here. Where is, okay. So there's our velocities right there. How different will this look if I do a point velocity here? It is different for sure. Not drastically different, but different enough. I'm just thinking here what we're gonna do. Yeah, because that's that's the problem, is that when they get deleted like that, they jump around. That's probably fine. We don't have to do this. That's cool. Let's just do that. That'll give us our velocity. And we want to have like a camera that we could... Oh, question. Why would the speed attribute make the boxes rotate in the end? It's not the speed attribute that's doing it. So if we undo the speed, that really doesn't change anything for us. The reason that we're... Hey, Brandon. I'm glad you get to see one. That's awesome. So the reason that this point velocity is causing the copy to points to do that is because when you have a velocity attribute on your geometry, that vector is actually something that it rotates with, almost like kind of how if you have a normal on a point, it'll rotate it. It's similar with velocity. Since these points don't have normals on them, the velocity is going to be driving that or it's going to be rotating them more or less. So that's the reason that happens. Okay, let's do this. Let's just put a null down here because we're probably going to grab it from here. We'll just say 2 cops. So, and let's put a camera in here. So, hey, you're welcome, Fractaler. So let's do a camera, lock it down, and just actually move this around like that. And let's see what our whole, I'm just going to undo this and just kind of get us in a better position here. Also, I'm going to change this, the view, to be 1-to-1. Yeah, let's just do this. 1024 is probably fine. So we can have this rasterize our geometry at any direction. So let's just kind of see where we're going here. I'm just going to pull back maybe a little bit. And let's turn this back on and just see how this goes. Yeah, that's working pretty good. Let me just see here. What if I change this to be 0.5? And I'm just going to make these boxes a little bigger. Let's do that. Maybe a little too big. Let's do that. Okay, cool. And maybe, just maybe, I'll do a few less of these. Just so it's a little, maybe a little less jumpy. Cool. Okay, let's do that. That seems good enough. Hey, Carlos, welcome. All right, so let's do this. Oh, you know what? The other thing I was going to do is let's randomly color these. So let's just do a color here. Actually, I'll just do an attribute adjust color. Do this up here. We'll just say color map. No. Random. There we go. Sorry. All right. So let's just grab something here. We'll just use the infrared one right now. That's fine. So now we should have colored boxes. Cool. And let's take this and just do a little bit more with this. All right, just kind of playing around with this a little here. Seeing what comes up. Okay. When I'm, let's see here. Fractaler saying, when I imagined how I would do the random noise in a VOP, now I see a lot better what you meant. Thanks for the clarification. Yeah, no problem. All right. So we've got that all taken care of for right now. I think that'll be good. We'll kind of see where we go with this. So I am going to do, let me think here. You know, I'm going to do a Copernicus network up here. Let's actually call this something a little different. Geo random boxes. I'm going to color this green. And let's do a cop network here. And I'll just say sim flow. Sure, something like that. And that gets to be purple. All right, and I'm going to make this a little bigger here and bring up a operator, the parameters up here in the corner. So let's do a SOP import. This is going to be asking to use an external SOP. And we'll grab this 2 cops. So now we've got our geometry brought in here, 2 cops. Cool. So the next thing that we want to do is let's also bring in our camera. So let's do a camera import. And we're going to grab camera 1. And now we have that. And what we're going to do is we are going to do a, let's see, setup, rasterized setup, I believe. No, sorry. It's a rasterized geometry. So we're going to wire the geometry in here. And what you'll see by default is that this will take a camera that's kind of in the it's basically at an origin camera, more or less, just kind of pointing straight down the z-axis. And if we wire this camera reference in here, it's actually going to be looking from this camera direction, right? So this is getting rasterized just like we would see in this view here, right? So that's one-to-one rasterization. It will also bring in the camera resolution, so keep that in mind that it will use that. So we can also set it to be a proxy, and it's going to go a little faster as well here. If we turn this off, it's still going pretty quick, but it will go a little slower. So, all right, so we've got our geometry rasterizing here. So let's pull in a couple things here. We have the alpha so far. Let's pull in an RGB, which will be CD, so we'll have that. And then let's also bring in an RGB that will be the velocity. So, oops, if we click down here, we can change this to CD. Okay, thank you. And we'll see that these colors are going to be sort of what we expect to have here. Yep, we got a little slower rasterization there, so I'm just going to click the proxy on just to speed it up a little here. And this should be at half resolution. Yep, 512. So, okay, and then we should also have the velocity, which will just basically be pulling velocity data from each of these objects. Some of them you won't see if the velocity is negative, right? So you won't see it in that case. But here you should see the yeah. So that's all the velocity information getting brought in. And I'm just going to switch this back over to CD, and then we'll just have these. Hey, tub of monkeys, welcome. So this color is mainly what we're going to use for this effect. So I'm going to close this down here. Here we go. And let's drop down a flow block. And so what we've got here, I'll zoom in a little to see, is we have color, V, temperature, feedback, and pass through. Now the first thing I am going to do here is I am going to, sorry, I'm just thinking of a few things here. Okay, so I am going to add a color for the background of this. So let's do a constant. And for this, I'm going to make sort of a grayish type color here. I'm going to make this RGBA. We'll make this, I don't know, like a grayish kind of color here. Sure. Yeah, something like that. Looks great. So we're going to wire this constant in here. Oh, I'm on frame 191, so it's trying to calculate up to that, which it does fairly quickly, but I'm just going to jump back to the beginning. So this now is a flow block, and it's actually simulating. It's calculating the flow. However, we don't really have anything all that interesting. I'm also going to change this to the front viewport just so we're in a nice kind of orthographic view of this. So what we need here are a couple things. Now, I don't have really a temperature that I want to feed into it. I mean, I could feed that in for sure, but I definitely have a velocity. So let's think about what this is doing, right? So this is a flow block, right? And so this is like a simulation. And so we're feeding in to these inputs here, our kind of starting point, right? Our starting kind of state for our simulation, just like we would in any other DOP simulation. And so if we feed a velocity into there, it's not going to update every frame, right? So that is just going to be one velocity and that's it. So like if I take this velocity, which you can see we have a different color difference here, right? So if we hover over this, we can see that this needs to be a UV, which is just a vector 2 basically. And so what I can do is I can do RGB to UV, and we can wire this velocity in here. We could put our UV in there, and let's see what happens. Oh, I should also, could probably do this. Let's do an RGB to RGBA. And let's bring this in here, and we've got the alpha channel. And let's see, we can just, could probably just blend this here. Interesting. Why do we have multiple tiles happening here? That's really strange. Sorry. Not sure why that's happening. Why would I have multiples there? I'm also going to change the background to dark so I can see what's happening here because that is really odd. Why is it doing that? Well, I'm trying to do I'm doing something different here than I did before, so I guess I that's what I get. Border auto? I mean, I don't know. Let's see. Let's do a blend here. Let's try it again. Oh, okay. Interesting. Weird. That is really strange. I don't understand why that would be doing that. Oh, I see what you're saying. I see what you're saying. So if we do auto here and then come up here and do a constant or something. Yeah, interesting. Right. That's really odd. So actually what I need to do here is this and then use that maybe. What? No, maybe it's here. Yep. Okay. Sorry. There we go. Now we've got it. Now we got it working. So we should be able to do this and this. And I think all we're going to get is really not much of anything. It probably moved a little bit. You're getting a really tiny movement. Not much at all. Hey, cool VFX. Carlos is okay. Carlos is saying, I think Copernicus has UV coordinates from -1 to loop. It seems camera outputs 0 to 1. Interesting. Well, it seems like we've fixed that, so that's not a problem. It would seem. Also, I'm going to move that to the origin, and then we're in a little bit better shape here, maybe. All right, let's just double check what's going on here. Yep, there we go. Maybe that was my problem, is it wasn't at the origin. So this is our simulation right now. Super exciting. It just goes blunk, and that's it, because it just gives us the start condition. So that's not really what we want. Hardware question: am I using any APC on my system? I am not. Not familiar with that term. No, I'm not. I don't think. Okay, so here's what I'm going to do. I'm going to get rid of this. I'm going to get rid of this. And I am going to get rid of this for now. I'm going to delete that. And we're just going to leave this gray coming in because I want that to be the background. So what we're going to do is we're going to use our cool little ear here, and we're going to wire that into the pass-through. So this is now a cable, and this contains all of these inputs. And we're going to be passing that through the flow block into the solver. UPS. No, I don't have a UPS on my system. I do not. I should, but I don't. So the feedback is going to be what's, I believe that's, actually I'm not sure what the feedback is. I was thinking that was stuff, multiple like other layers and stuff like that it would like loop through, but now I'm not sure. What is feedback? Anyways, this pass through is going to allow us to be able to get a cable in here and use it for whatever we want. So if we use a cable unpack here like this and set the fields from the input, now we have all those same fields inside of here in our flow block. And so now we can actually access them internally. And so I look tanned. I haven't been on vacation, so maybe my camera's just a little different right now. But no, I have not been tanning. So now we have this cable impact, so that's working. Let's do this. We can do the same thing with the color. So let's do that. Let's do a blend, and we can take the color as the background, and let's do that same thing we did before, maybe, or no, let's just take the color in here, and then we'll use this as the mask, and let's just see what we've got going on there. Yep, perfect. That looks good. So this will now update with those. And so if we took this and wired this in here and looked at the end result, we should see something start to happen here. And so now it's like a painting, right? So that's not exactly what we want to have happen, but it's kind of interesting, right? Like, yeah, it's something. Not my favorite thing that I've ever done, but it's a thing. kind of a little accumulation solver. So that's kind of neat. But this certainly is not what we would want. So let's play around with this a little bit. So like we might do in any type of like accumulation or like anything we do inside of a solver, what we want to do is kind of slowly have the source go back to where we had it before. So what we could do here is actually pack this color in as well. I just thought of that. All right, so let's do a cable pack here. And I'm going to leave this wired in over here. So there's our cable pack, and we're just going to call this constant like that. Actually, we could have just set it from the input. That's okay. And then I think we can do a cable merge. So what I'm going to do is take this input cable, merge this in. We should have a merged cable now. Let's see. I think that's how that works. Could be wrong, but we'll see. Everybody likes the effect. Yeah, it's something. It's a something effect. Oh, sorry. I want to do a union, I think. Then fields from input. There we go. Perfect. That's what we want. All right. And then we should have the constant. Yep, we do. Okay. So what we could do now is we could do an add here, right? And take this color. And this will be happening on every, like, at the beginning of each frame, basically. So we're going to take the background. You're going to forget how to do karma or sims. No, I'll be good. This is still a little foreign to me, but so what we're going to do is we're going to take this, and every frame let's actually, you know what? No, we can do a blend, and let's just see here. I'm going to hit play a little bit, let this go. There's our simulation, and we can kind of see how we would sort of tamp this down, right? So this is bringing in that color, and then every frame we would, reduce it by a certain amount back to this like original kind of color. So we could do just a little bit each frame. Let's try like, I don't know, let's do 0.75 for right now. So that's going to be what we kind of reduce it by every frame. So it's going to trail these values off. So let's take this and wire this in here. So now this is kind of making, kind of reducing those values every frame. And let's see what happens here. Yep. So we're getting a fade. It's maybe a little too extreme. Let's do 0.5. Cool. I mean, it's still not really doing much of anything, but we're getting values that are like fading in and doing their thing. We could maybe go down to 0.25. I don't know why that's flickering so much. I'm not sure why that's flickering so much. It's kind of weird. It really shouldn't be. Huh. Interesting. So Carlos is saying, what if you plug things in directly without a pass-through? So first of all, if you plug things in here without a pass-through, it's just going to take the values once at the very beginning and just do the whole simulation from there. And then to change this, yes, I think if you up the number of substeps, you would get less banding probably. Let's see here. I think. No. I think it would be this rasterized geo would need to... I think this would need to adjust, and I don't know if there's a way to easily do that. Yeah, I don't think any of these things are gonna do that. Yeah, everybody's talking about UPSs. So yeah, I don't think that we will be able to really remove that banding, but that's not really how it's going to end up looking. So we won't worry too much about that. Hey, Baymax, welcome. All right, so let's also... Weird, how did I get P in there? This should be V, not P. That's weird. Okay, so what we're going to do now is we're going to do an RGB to UV. Wire that in. What do you mean RGB is missing? What does that mean? Sorry, just going to check and make sure that we actually have the V attribute there. We do. Huh. Let's see. Does that do it? Why does it think that that's P? That's so weird. Huh. Okay, well, that's really strange. Not sure why that is. Maybe it's something to do with this cable merge. So the banding is related to the animation, but it really has to do more with how the rasterization is happening, because this isn't re-rasterizing, every intermediate frame, right? I think if we change this to fractional frames, I don't think this would... Oh, it does. That's strange. I thought it wouldn't do that. Very strange. Let's see here. Yeah, because the sub-steps are within each frame, but it's not like global sub-steps. That's really strange. Not sure what to say about that, because here you're going to see it's got the same exact banding. I feel like there needs to be a global checkpoint rate is a little different. So cache frames and checkpoint rate basically just means what's going on down here. So if you watch here, every 10 frames there's going to keep 10 frames of cache, right? Then there's also going to be a checkpoint frame every 24 frames. And what that means is that this is, we can just move it back here. It only has to calculate 10 frames from this 24th to be able to move through. So it kind of saves those, and it re-simulates these, right? When it needs to. Like here, it's going to start from 72 and jump to and resolve to 79. So it's just like a little bit, it's just a little bit of a way to make it a little bit snappier without having to cache the whole timeline. Could be the proxy, but I don't think so. Let's take a look. That's just going to slow everything down, and we're still getting the banding. In fact, let me turn this 0.25. Let's do that. Yeah. It's not that, unfortunately. Hmm. All right. Well, we'll have to just kind of work with this here. I didn't even figure this out before, so I think it'll be fine. I'm not sure why we can't get any more like temporal resolution there, but anyways, I'm gonna open both of these, the X and the Y border. So we're just gonna open those. That's just the border of the simulation, so we're not getting like weird reflections and stuff here. I kind of just want the velocities to kind of scrub off into infinity. So let's do that. And then, okay, so let's take the velocity here and we can add that in. So let's just do an add node here. And I'm going to take the background value, which will just be our V, and our UV is the foreground here. And let's just add that in. And let's change that to be the V there. And let's see what starts happening here. So we're going to see a lot of, velocities and things like that happening. Cool, 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 cool. And so again, we could take this and change it way down. And we could make this, the color now last a lot longer, right? So it's not going to fade away quite so quickly. So that is just going to keep the colors kind of swirling around a bit longer. If you did 0.5, obviously it's going to kind of just smooth away a little quicker. You're not going to get quite as much as it. So let's do 0.25. That seemed pretty good. Like we had a little bit of mixing going on, but not all the time. So it's kind of cool. Getting different colors in there and different swirls and swooshes and things like that. The other thing that we can do is we could add a little bit of noise into this, right? Into this source. So let's do that. Let's do the fractal noise 3D. Is that what we want? Probably. And let me just think here. Let's do UV. And what we can do is we can take, let's do an overlay, I think. That's probably not going to do an overlay. Let's do an overlay here, and we'll do this with that, and we'll take the noise into here. And let's also take the mask from this alpha, this intrinsic alpha, and that'll only put the mask value in there. Now this is from outside of this block, so I don't think, Oh, there we go. Okay, cool. Cool. It's like, that's not good that it's outside of that block, but we're good now. All right, so let's just sort this out a little better here. Something like that. Great. Might just move this down a little bit here so we have a little more room for the cables to unpack there. Nope. Okay. Wasn't sure if that would work or not, but it did not. I was not happy with that. Oh, it did not like something there. Let's see. Got that. There we go. No moving. All right, so we've got some noise on that there, it looks like. Let's do this. Do we have a way to animate this? Yeah, let's just do this like $T or something like that, just as an offset. Great. Okay. And that'll just make a little bit of noise here for it. Let's see here. What if we up the amplitude of that? I wonder how that'll... Yeah, that's kind of cool. Yeah, maybe it's a little too much. And also I'm going to turn this down just a little bit, maybe to 1.5. Just keep those colors around a little longer. Yeah, that's nice. Now the other thing that we could do, with this is output. Well, I guess if you were rendering this, what you could do is you could use the sorry, I'm just thinking of something. One other thing here while I'm... Where is the cache for this? Because it seems like it's resetting, and it shouldn't. I've got plenty of RAM. So what you could do out of all of this is take that simulation, but also use something like this intrinsic alpha over here and use that as like an emission source, you know, on your texture. Maybe we'll play around with that depending on how long the rest of this all takes us. But okay, so we've got our random geometry boxes. We've got our sim flow there. Let's now do another geometry node here because we can start to work with this. We can do sim Vellum. And I am going to put this back because this will be a little easier to work with Vellum. Let's just do a planar patch, classic, go to perspective viewport there. All right, I am going to grab all of the seams. So we've got all of those. And let's call this, we'll just call this Copernicus cloth. And then we've got our things there. Actually, let's call it Cops cloth. And let's make it a little bigger. But I don't know. Is that too big? Doesn't really matter. Yeah, it's fine. Yeah, that's cool. Actually, you know what? No, let's make it smaller because then we've got huge scale on our hands here. This is a 3 foot by 3 foot piece of cloth now. So the mass should be appropriate to that. Okay, that looks pretty good. Let's do a Vellum configure cloth. Okay, so we've got our cloth here. Let's just pin the top for right now. We can always pin more of it. And let's do a Vellum solver. Cool. Let this open CL kernel compile real quick. Super exciting stuff. All right, so we've got that. Now, how are we going to bring our attributes over? Well, we have our attribute from map, right? So because this is a simulation, I don't want to put all these animating attributes into into this stream because I need to have them in the solver. So I need a way to be able to pull those in. So I'm not going to do that this way. I'm going to go into the solver. Yep, let me do that. I'm going to go into the solver and do things that way. Hello? There we go. Thank you. Can you go away, sir? Okay. So let's also do this. We need a UV, right? Because all of that stuff is being done in UV space. So so let's do a UV project. We're just going to project just a simple grid here. That seems fine. Good enough for me. Yep. All right, cool. So let's take this because we need the UV to be able to project our texture on here. And let's grab our file. So actually, you know what? I will just change it like this because I can make this a little bit bigger, a little easier. So let's do this. So what we're going to do is we're going to do an op call. And so we're going to say, I could maybe just do oh, that's weird. Huh. That's weird. Okay. Anyways, let's just do a direct path to it. obj/ we'll do sim flow. And then we need to set up some stuff in here. So let's just leave that for right now. We will talk about that in a second, why they look distorted. But okay, let's output some of these things. So let's do a null here and just say out color. Yeah, maybe I did need a quotation mark on it there. That's a good point. We'll say out val. And then if we want to do the alpha, we don't need to have that go through this whole thing. So let's just do this. And we'll say out alpha. So this, it isn't, if we look at this grid, there isn't actually any distortion. But when we look at the attribute from map, if we go back to the default here and click on this, the reason that it looks distorted there is because we're only able to put attributes from it onto specific points. So we just have to, it's looking up basically the closest point and trying to interpolate between it. If you look at this, the UVs are basically perfect. They're exactly where we want them. It's just when you try to move attributes over here, that's where that's where the colors are getting off because it's saving them to the points. So, hey, Jack, welcome. Nice to have you. All right, so let's try this again here. So what if yeah, that's a good point. Let's try that. There we go. That's what it is. You're right. Thank you. It is a quotation mark. So let's do sim flow and we'll do out color. That's good enough. And let's see here. Nope. Why is that the case? Why is that the case? Okay, so I'm going to do this. So we'll do obj. There we go. So we're getting the color here. The other thing we might want to do is just reduce this a little bit. So let's maybe do 125 on this. And that's going to make this even more resolution. And so we're going to be able to see that a bit more. I'm going to turn this off so we're not looking at the all the UV coordinate things there, but it's looking pretty cool. Got some color on there. Now this would obviously look even better at render time because this is just a texture, so we wouldn't really be running into that same issue there. So that's going to be our color attribute. We don't really need that just yet. So let's turn that off. Let's open this back up. And let's do this. So I'm also going to do an attribute from map that's going to do a V attribute. And so I'm going to Alt E on that one there. And we're going to say out vel. There's our velocity. Now, the weird thing about this is oops, maybe I don't want to do that. I guess I don't really need to do that. The weird thing is that I'm actually trying to put this to the V. Is it doing it to V? Sorry, I just want to look at that. Yeah, it is adding a V attribute, but it's also changing the color, which is super strange. So that's why we're just going to put this at the end. So that's the velocity. And that's really kind of the main thing that we want to tweak and mess with here. It's very fun to look at. So we could do this like this, and now we've got color and velocity. If we look at our trails here, oh, hello. It looks like jellyfish. Yes, it does. There they are. Okay. They just weren't showing up on that first frame. So here's our velocities. The other thing that I'd like to do probably is try to tamp down some of these background velocities. Actually, I kind of forgot to do that because we just have these kind of just swimming around and they're just a little bit too much velocity all the time. So let's go back over to the Copernicus sim here. I'm going to stow that away. And let's do sort of the same thing we did here that we did with this up here. So we just did a blend into it. So for this one, it'll be a little different. We could just do a add. Actually, it would actually be a subtract, wouldn't it? So we'll do a subtract. Or it could just be a mix. That's fine too. Or blend, I mean. We'll just do a constant here just to make sure that we're dealing with the right thing. And we'll just put this at 0, 0. So let's just get some velocities in here. So we're making sure that we're dealing with the right thing here. And then there we go. So we could blend in, I don't know, a quarter on each frame. And so what we should see now avoid negative values. Well, it's actually kind of okay to have a negative value here, right? Because it's going positive or negative either way. But yeah. So let's see here. So we should have the background be quite a bit. Yeah, it should stay a little bit darker like that. If we turn this off, we'll see that the background retains this lightness. So when we click this on, it kind of dims it all down. And that makes this a little bit more of the effect that we want. Might not be quite as dynamic here. Let's just see what we've got going on. Yeah, it's a little bit more static there. Like it's gonna kind of like have a drag to it, right? Still kind of interesting. Let's maybe turn that down just a little bit. So we could say 0.1 maybe, or is that more? Sorry, I can't remember. No, that should be right. That's how much sort of drag we've got going on here. Maybe we'll do 0.15, something like that. Kind of split the difference a little. Cool. All right. So now we've got those. Let's go up a level here and go over to our... So now Carlos is asking... So now we dampen the velocity as the default velocity based on fluid dynamics. It's not really fluid dynamics, I don't think, per se. I think it's just... I think it's this like pressure projection thing that's happening here. So there's a flow project. I think it's this that's doing the actual like the project non-divergent multi-grid. I think this is basically what's happening here. So it's like it's a pressure projection is what's doing it. Baymax was asking a question of a non-related stream question. Do you know any good resources for showing how to scatter some fixed size props and assets procedurally? Yes, it's incredibly difficult. I've done it before. So Baymax, what the problem is, I think it's kind of like not an open problem, but it's not really like a solvable problem. Like if you're giving yourself a city grid that you need to put buildings into, the best way that I've found to go about it is kind of like eating chunks away of the block and like setting up like a vex system to kind of like calculate the bounding calculate the bounding boxes, then figure out if they can fit into the remaining sections of the street kind of grid, and then eating away at that as you go through it and kind of placing the buildings in it. It's really tricky. It took me I'm not super smart with that kind of stuff, but it took me probably a couple weeks to figure out a good process to like get that all going at a previous job that I worked at. I probably could do it better now, but obviously that was in the midst of doing other things as well. But yeah, it's definitely not simple. It's a tricky process. See you, cool VFX. Thanks for joining. All right, so now we should have a little bit more, controlled velocities. The background is gonna kind of, reduce to 0 a bit more. So we've got a little bit more locally, these velocities will be quite a bit higher. Okay, so that's good. Let's put a null down here. And I think we actually don't even really need that. We can just call this and say, yeah, I mean, that would be a big stream, man. Yeah, I don't know if that could take me quite a while to remember how to do that. It's a good suggestion. I don't know. All right, so let's see here. What are we going to call this? We'll just call this vel. I'm going to grab that velocity. So let's go inside of our solver here. Let's do a pop wrangle. Let's grab that for our input. So we're going to grab a sop input here. Let's move this over. And nope, that's 2 cops. There's our vel. So we're going to accept that code. All right. So let's do this. We want to bring in the velocity, right? So let's do a vector. I'm just going to say get vel, something like that. And we're going to use a point lookup. And for this, we need the geometry attribute point number. So the geometry is the input that we gave it on this node. So it's going to be 1. Then we're going to be looking for v. And we're going to be looking for the point number because in Vellum, the point numbers match up to the geometry. So that's fine. So we've got this get velocity, and then we can do v at v plus equals, we'll do get vel. And so that's adding the velocity there. What we could also do real quick is we could do a float We'll do this called velocity scale, and we'll make this velocity scale like so. We'll add that in, and so maybe we'll just do, I don't know, like 1.5 for right now. So we'll do get vel times vel scale. So now we're multiplying this velocity here that we're getting by this velocity scale. That's just this parameter coming in. And yeah, let's see what happens. I'm going to wire this in at the bottom. So we've got our color after this. Oh, excuse me. Pardon me. After the simulation. And yeah, that's doing some wacky stuff. A little too intense. So maybe that's a problem. Let's go back here. Maybe I should do this at like 0.1 instead of crazy multiplied. What did I do differently here? Okay. I think maybe what I did differently, if I'm remembering correctly here. Okay. So why don't we grab the alpha channel and we can use that to create a kind of localized zone where we're actually adding the velocities in, just so it's a little bit tighter maybe, so we're not adding velocities everywhere. Yeah, like masking the velocities. I think I might have done that in my other example. Maybe not though. Let's see here. Let's just like scale this way down, just for kicks. I'm just going to scale it to 0. Okay, we've got something weird going on here. Sorry. Okay, so we've got something else happening. What is going on here? Why is that? Oh, I upped the scale of it. That's what it was. Yes, it is related to the Vellum setup. Let's add some substeps, a little bit more constraint iterations here. Yes, it definitely is related to that. Yeah, because when you change the resolution of this, that can cause some of that to happen. Damn, I'm gonna have some more damping on that so it doesn't maybe bounce forever. Okay. So that actually was not the problem. Okay. Let's put this back to 1 and see what we get out of this. Yeah, okay. So let's turn the... Let's actually turn that down. Let's see if we can turn the bend stiffness down too, because I feel like... Yeah, there we go. I feel like that was too high. Okay, so maybe there is good. All right, so let's do the colors here. We should be able to see that start to like affect it. That's kind of funky where it goes like up like that. Yeah, so you can sort of see where these are like grabbing on, right? And like how they're affecting the cloth. So that's kind of cool. Let's see here. Oop. Yeah, let's like flipbook this or something. All right. Just set it to that size and let it go. It's a little crazy, but I think the idea is getting across. I mean, you could certainly slow it down if you wanted to. Yeah, so it's kind of, I don't know, it's an interesting little effect. Yeah, it's pretty interesting. And you can imagine that this doesn't have to be just on a flat geometry, right? Any geometry that has what do you call it? UVs on it would be able to handle this, right? This is just UV texture, so you could apply this to any geometry, right? I'm not really sure exactly how that would work with like... Yeah, let's try it. Let's try it. It's doable. Okay, so we got that. Let's see what we could do if we did it with... let's try the pig. All right, so let's grab the pig head here and let's remesh. Hello. And harden the UV seams. Okay, maybe something like that might be a little too much. Let's do that. And then let's do a Vellum strut soft body. All right, so let's do that. And do a Vellum solver. Just adjust the ground plane here, or give it a ground plane. So ground position here. Like that, cool. I'm gonna turn off the shader though. And let's grab this, and I'm just kind of curious what this is gonna look like on here anyways. So let's do that. This pig's going into space. Yeah. That's where they belong. We've learned that years ago from Mr. Henson. All right, so let's copy this over as well. So now we should have a velocity on here. Oh. The only problem with this is going to be that it's an XY position. And so it's only going to stretch it in the X and Z axis, or the X and Y axes, sorry. Probably would have to do some fancy vector math here. Not fancy, but in order to have it properly orient. It's almost like you'd need like a world to like local transformation across it or something. But we can play around with it. It'll still work. It just is going to stretch in a weird direction. All right, so let's grab this. Paste it in here. Nope. Copied the wrong thing again. Copy. Paste. All right, I think I'm going to need to up the scale of this velocity a bit. So let's do it to like 4 because we're going to be dealing with gravity here. And I need to up the strut strength as well here. So let's do that, I don't know, 1,000? Mm-hmm. Nope, that's too much now. Let's do 100. Nope. Sorry, I'm going back to 10. Let's try it. Oh, I'm at 1. Picked the wrong one. All right, let's do that. Let's see some colors on this thing and see what that does. Yeah, I mean, it works. It's not great, but it's something, you know. I think the problem is it's only really moving it in X and Y. So because of that, it's not going to exactly do it. It's like activating in those spots. Yeah, you could sort of do that. Be a little weird. You know what you could do maybe? Oh, how do you do that? Because if you moved the geometry into UV space, like if you split the geometry and moved it into UV space, that would actually... All right, I'm not going to do that right now. That's basically what... So like if you use this Copernicus, and if you grab SOP geometry, yeah. If we did this and then just put a pig head in here, for example, and then we go up, and then we do a rasterize setup. Basically, if we did this with it first and then applied that those velocities to it and then moved it back in space, that should actually get them into the right orientation, I think. But in this, this is what's happening inside of there. Vertex split. I think it's actually just this, right? It's really just this. Space, yeah. So it's vertex split, attribute swap, then a transform. You don't even really need to do that, probably. Yeah, that's actually not that hard. Let's see. So what if we do vertex split? What are we doing there? Sorry. Allow editing of contents, up invoke. So we're just using the UV attribute, promote to point attribute, and then we're swapping UV and P. You probably just want to swap them, but okay. So yeah, so here we would do this. So that's going to split the vertices, and then we can do attribute swap. And actually what we could do is a rest as well, a rest position, because then we can use that to set it. Then we can do here, the source will do UV to P, and we'll do a copy. Hello? Oh, this. We need to promote it to a point attribute. There we go. And then if we do this, hey, that's something. Okay, so that's all along like that. That's cool. And then what if we... Well, I guess we don't even really... It doesn't even really matter to put it back. I mean, we can. Let's see. There's just a rest position. I wasn't sure if there's like a restore rest. Let's see. How does that look? Does that actually work? That does seem to be right. Yeah. Yeah, that seems to be doing something better than what it was doing. Let's see here. Let's look at that versus this. Also, just realized that I was pointing this at the wrong thing. So that would be better. Let's see here. Do we have any difference? No. Oh, that's too bad. I was thinking it might. Oh, well, we gave it a shot. What about this? Would this do anything? Yeah, the thing I was thinking was that the rest might rotate those vectors back. Like it might put those vectors into, like so that it's parallel with the surface. That's maybe what I was thinking. But I'm sure there's a way to do that, but I am not smart enough to do that. So that's okay. We'll just let it do this and call it good. And let's actually move on. I think it would be cool to look at some look at a way to render this. I think that'd be kind of cool. So maybe we just take this and we do a null here. Zach is saying I'd be surprised to see a difference. The cop is only outputting X and Y with no Z velocity. That's correct, yes. So what I was thinking possibly could happen is since we're transforming and moving things, that maybe those vectors would get transformed, but there's no rotational transform happening there. It's just a positional transform. So that was stupid on my part. You really need an actual, some sort of transform matrix to be able to rotate those properly. So you'd need to like figure out a transformation matrix that goes along UV space, I think, and then transform those vectors, like multiply those vectors from their flat state with all of those, you know, all of those transform matrices, like just flat, and then rotate them like a rotational matrix to the position of the you know, into the coordinates basically of the geometry. But that's fine. I don't need to worry about that right now. All right, so out Vellum Sim. Cool. Let's do that. And I'm just going to bypass this. We don't really need that. So let's do this. The only thing I will want is that string right there. So I'm just going to grab this string, copy that over. All right, let's do a lop network here. I'm just going to change something over here. Cool. Let's do a, let's call this, I'm going to show my thing here. We'll just call this cloth. And let's grab this from there, out Vellum Sim. So that should bring that over. Cool. Actually, I'm just going to add this to be... I'm just going to do this. Just kind of play around here a little. All right, so we're going to do that. We're going to merge this in here. Zach is just saying, could be hacky and use a black and white version of the color map used to mask a pop wind limited Z direction in the solver. Yeah, you could do something interesting to like fake some extra Z, you know, velocities to add them in there. Sure, you definitely could do something like that. All right, so we have our cloth here. Let's do this. Let's down, and let's just call this cloth cache. So we'll just have this in the background running. Put that in sim. I don't really want the hip name in there. Save to disk in background. Yes, go for it. Okay. So we'll let that save out. You can. Yeah, you can cache again. You know, I could save this out to a USD file, and that technically would be better. Yeah. Forget it. I'm just going to cancel this. Let's delete that. Let's do a USD export here. Hey, Graham, how's it going? Oh, thanks. Yeah, it's just a fun little idea. I saw it in the I think in the keynote or something. Let's see here. What was I doing? Oh yeah, in Solaris here. I'm gonna grab this. I want to make sure that's the same path. That's where I wanted it to be. I don't think there's going to be anything more than that. So this is the only thing that's a little weird is you don't get to see your path here when you do this, but this should be fine. And let's do this. We'll call this USD, and we'll just call this cloth sim anim. Okay. We'll render frame range, configure. There's not really anything else we really need to worry about there. Okay. Let's do that. Export. We'll save that to disk. Let that go for a second. So the interesting thing here is that, well, let's look and see the difference here actually, because now I just want to kind of play. I've had my Copernicus fun. Let's see how USD works. Yeah, I agree, Jack. Graham always does some really cool stuff in his tutorials. He's always up to something interesting for sure. He's been playing a lot with Copernicus as well. A lot of cool stuff. It's pretty fun. You can kind of just whack things together and oh yeah, that's a good idea. Transfer your V to UV to 3D space. You can use maybe a polyframe and an attribute orient. Oh, that's interesting. Attribute orient, huh? Interesting. Can drop a tangent field on the pig head and then use X and Y as a multiplier. Oh, yeah. Yeah, I could see that, right? Like you would. Right. So then that would move it in the different directions. Yeah, I think that makes sense. Okay, I'm going to do another. Actually, I'm going to do this Vellum IO. I keep changing my mind. All right, let's do that. This way, if I want to save it out, it'll be ready as well. So we'll call this sim. And just that. And we'll do cloth cache. I think that's what it was called before anyways. But that's fine. Save and continue. There we go. All right, so this way we still have our cloth sim happening here. Whoa. Hello? What the heck? Did I break something here? Huh. That's interesting. How did that happen? Let me just see what happens here. Okay. Interesting. The save to disk and background didn't work. I wonder if that's because it wasn't properly grabbing the Copernicus? That seems like a bug to me. That's an interesting one. Anyways, all right, cool. Well, that works regardless. All right, so we exported the USD. We export. Now we have this cloth cache here, so we should be able to come into Solaris. We can do this, and this is fine. We're getting frame rates, but I believe if we do this, an asset reference, and load this in with our USD file, way faster. Got to turn it down. Okay. So the other thing we want to do here is that's the only bummer. It named it USD export 1. Well, that's okay. So the reason that this is so much faster is because of this little guy right here. Because this is live inputting every single frame. So every time we scrub this around, it has to recalculate the transfer between SOPs and Solaris. So that is the problem here. And when we look at this too, like our mesh, for example, just gonna make this a little bigger here. Should be able to do this. Yep. And if we look at something like points, which is our actual point positions, you can see we have this time samples right here. And that means we're only importing one time sample at a time, right? So it doesn't really know anything about other time samples in here. So what we can do over here though, is this, if we click on the mesh and look at its points, we have 240 time samples. So it does not have to re-import these samples. They're always available. They're always there. And you can just click and scrub, and it's basically instantly going to have all that information because it's loaded it all onto the stage. So that's really the way that that USD wants to work. So we'll just leave that up there. This we're going to say ref cloth from disk. No, it's not actually updating the name there. And the reason that I just put this in /world was because if we had it in $OS, it was trying to name our top level thing this, and I just want that to be world. So what it's doing is it's finding a primitive here, and we could change this, right? We could reference a specific primitive. We could come in here and go like this, USD export like that. And now it's just going to be the mesh underneath that primitive. And then from there, what we could actually do now that I'm thinking about it is we could say /world / geometry / cloth. And that should now do it. And so now you can see we have this cloth component with the mesh, and that's all good. So I've just kind of rearranged some of our hierarchy here. So we're taking this specific primitive and placing it at this specific path. And so that's why we're getting this updated hierarchy here. So anyways, all that to say. All right, so let's do a quick surface material because this is quick and pretty easy to get a Copernicus thing in here. So let's set or create here. I think I still have this thing saved here. So that would be this. So that's going to be our color map. And let's do an assign material. And this material is actually in a weird spot. So I'm going to change this to /world/materials. And we're going to call this cloth mat. So now we have our materials in here. We can assign those. And I'm going to just put that, I'll put it onto the mesh. That's fine. So we'll do primitives. There's our cloth material. And there's our color. So now we're seeing our color applied there. Weird and wacky stuff. Okay. Now, obviously, that is pulling that texture every frame, so it's slowing it down quite a bit because we need that from Copernicus. Now, if we save that out as an image texture sequence, be a lot more efficient. So something to keep in mind there for sure. I think if we turn this off, it should still play back pretty quickly. Yeah, pretty quickly. Not as quickly, but pretty quickly. Yep. All right, so we've got that. Let's just do a few more things here. Let's see. Let's throw a camera in here. And let's do maybe we'll do a dome light. And let's do the garage one, I guess. It's good enough. Let's see if Karma CPU hopefully won't freak anything out here. Hello? There we go. And then let's do our Karma setup. Now the question is, do we have a blur in here? Kind of does look like we do have a blur. Let's turn this off. That off. Yeah, it does look like that's blurring, I think. Let's see. Do you have another frame? Yeah, I would say it's blurring. Cool. Camera effects. Could just do velocity blur probably. Actually, what would probably make more sense is this one here, geometry time samples, and then you could up that a little bit more. And let's look at the cloth material here. So we'll change the roughness on this. I don't know, maybe do a little bit of sheen. I'm not a look dev person, but we'll do that. And then let's do one other thing that I was kind of thinking about, and that was with emission. So if we did, let's see, let's do one on the emission for right now. Let's do setter create. Let's say out alpha. Oh, yeah, Lucas, I actually did supply the logo and stuff like that as like a render challenge, like sort of like that, for the stream intro. That's a really cool idea. I mean, yeah, I definitely did that at one point, and I don't think anybody ever sent me anything, which is fine. It was a long time ago, but yeah, that would be a cool idea. Okay, so let's see here. What do we got going on? So the problem is that this is the color. It's just white, so it's, yeah, let's do this. Let's go back to 1 here, and I'm going to just multiply that in. So Set this back to Vulkan. All right, let's go back to the sim here. And really it's just this alpha. And if we multiply it, so if we multiply the alpha by the color, actually we just could do the color. That's silly. That's nothing. So we could just do the color. Yeah, let's do this. Out, emit. We'll just use that. Yeah, there we go. This is what happens when you work in Houdini. You complicate things just because you can. Exactly. Exactly, yes. So like that. Then you've got like your little random colory section here that's going to be kind of whipping this around at all different... How do I keep only getting blue ones? That's so funny. Definitely an orange one somewhere. I see there's orange. There we go. That's like a green one. Cool. So that would technically then, yeah, do the color stuff. And I could maybe turn this down a little bit. Maybe we'll do -1 on that. And then... Yeah, I think it actually has to update the Copernicus simulation, which is funny. Let's see here. I mean, if you were really doing this, you'd want to like write it out to disk or something. It's kind of funny. It's like making a weird little glow in there. Cool. Well, I think that's about that. I think we've got a nice little setup here. The only thing I actually should fix would be doing this properly, world lights, and then do /world/cameras/OS, and make sure this is updated like so. And so the reason I did this, just as a little aside, is because first of all, well, this render stays up here because that's like the default settings. If you open up this render primitives here and look at this, the primitives must be located under the /render primitive to match the USD spec. So that is like a default thing. That's where the render settings prims go. So we leave it up there. But if you have this world, what that means is if you reference in this scene, like if you hadn't done that, you would have to select one of these primitives to reference in, right? If you were referencing a file from disk, you couldn't reference in the whole scene if you wanted to. You'd have to sublayer it, which is fine, but there could be a reason why you'd want to reference in a whole scene and then place it somewhere else. So it just gives you a little bit more flexibility overall with doing USD stuff. So, yeah. So that is that. I think we're going to call that there. So it's a pretty fun one. Yeah, we got a lot of stuff happening there. So hopefully that was interesting to everybody, and it was certainly a lot of fun to come up with. And yeah, I'm curious to see if anybody else starts messing around with this kind of stuff. I think lots of people have already started playing with the Flow Solver and the Pyro and all that kind of stuff. So yeah, get in there and give it a try. But yeah, so that's where we're going to end things for today. If you'd like to join the Discord server, there's a link on HoudiniHangout.com. I would send a link, but it seems like it it said no. I think it didn't get passed to the chat. But yeah, HoudiniHangout.com. Check it out. And yeah, it should be, we'll see what we're up to next week. Oh, actually, I think we're going to have another guest next week. So that should be really fun. And I'll announce that when we get a little closer to it. But as for this file, if you want to play around with this, you can go on the Discord. There is a HH hip file channel that has a link up at the top, and you can go on there and download any of the stream files. So yeah, that should, like I said, that should do it for today. Thank you all for joining. Thank you for chatting. And yeah, have fun going and playing with some weird MoGraph Sim Copernicus stuff. All right, everybody, have a great rest of your week and weekend, and we'll see y'all later. Bye, everybody.